Identify the goal and formula for calorimetry. The goal is to determine the standard molar enthalpy of solution, delta H sol, of KCl in water, which represents the heat released or absorbed per mole of solute dissolved. The fundamental thermodynamic relationship used to measure heat transfer, Q, in a calorimeter is Q equals mc delta T quad, where Q is the heat of the solution, m is the total mass of the solution, C is the specific heat capacity, and delta T is the change in temperature. Determine the mass parameter. M, the total mass of the aqueous solution, is the sum of the components being mixed. M solution equals mass of KCl plus mass of H2O. Therefore, to calculate Q, the student must experimentally measure both the mass of KCl and the mass of H2O. Determine the temperature change parameter. Delta T, the change in temperature, is defined as delta T equals T final, T initial. Because the solute and solvent begin at the same temperature, the student must record the initial temperature of the water and the final temperature of the solution upon complete dissolution to find delta T. Determine the moles of solute, N, to convert the measured heat, Q, to the molar enthalpy of solution, delta H sol equals Q solution over N KCl. The student needs to find the number of moles of solute, N, using N KCl equals mass of KCl over molar mass of KCl quad, since the molar mass of KCl is a known constant derived from the periodic table. Only the mass of KCl must be experimentally measured to find the moles. Identify the minimum necessary data set. Combining the requirements from steps 2, 3, and 4, the student must measure the mass of KCl, the mass of H2O, the initial temperature of the water, and the final temperature of the solution. This list of parameters directly corresponds to option C. The correct answer is option C. Mass of KCl, mass of H2O, initial temperature of the water, and final temperature of the solution.